All right, I wanted to talk about dilution and solutions. I saw this on social media, and I thought it'd be good to kind of review how to do it and kind of show you how I do things. And I teach introductory chemistry as well as pharmacology. So it's really a lot easier to do this kind of math if you've already had chemistry because it's so similar to the stuff that we're doing. So here was the question that was presented, or something like this. How many mLs of a 4% stock solution do you need to compound 100 mLs of a 0.04% dilution in distilled water? And what I usually see is some kind of ratio proportion or something like that, where they just kind of start scribbling numbers in. And what I want to give you is a much more, I don't want to say better, but I want to give you a much more regimented or way that you can do it every time so it always works. So the first thing I like to do before I even mess with any equations is just to write down the variables in a way that's clear. So the first concentration, is 4%. Okay. The first volume, well, it's how many mL, so we don't even know. The second concentration is 0.04%, and the second volume is 100 mLs. So now that I have my variables, it just makes it a lot easier for me to say, okay, well, what kind of equation would have this kind of stuff in it? And the equation would be concentration of 1 times the volume of 1 is the concentration of 2 times the volume of 2. And we do this in chemistry all the time, where we take the molarity times the volume equals the molarity times the volume. And so somebody who's taken introductory chemistry is just going to have a lot easier time with this because they've worked through this type of equation. And it's just a matter of putting your head together that, oh, the M is a concentration, it'd be the same thing. Okay. Now this is where it gets a little bit tricky. It's a lot easier here because we have this horizontal equation. We don't have something over something equals something over something. We don't have to get something from the numerator or denominator, so numerator's on top, denominator's on bottom, and we don't have to get something from the denominator. All we have to do is move this C1 to the right. And the way that you do that is you multiply both sides by 1 over C1, and so this would cross this one out, and then the C1 would be under here. Okay, so this is what it would look like, the isolated variable equation. Okay, so this is isolated, the V1 is on the left, and C2 times V2 over C1. Now, this may be a little difficult for some because they prefer to have the number on the right side. You've always multiplied 2 plus 2 equals 4, not something equals 2 plus 2. Oh, that's 4. So it may or may not be difficult. I can do it either way, but again, I just prefer to just leave the isolated variable where it lay and just kind of work with that. But this is the equation that we're actually using. V1 equals C2 times V2 over C1. And then this is where you plug in the numbers. V1 equals 0.04 times 100 mLs divided by 4. V1 equals 4 mLs over 4. And then V1 equals 1 mL. Again, if you have questions like this, feel free to put it in either the YouTube video in the comments. I'm on Tony PharmD, TonyPharmD. I'm sorry, I couldn't think of anything more clever. Or you can always send me something at tonythepharmacist@gmail.com. But what I want to do is I want to show you how to do this in 5 seconds or less. And this is how I would have done it. I wouldn't have even gone through all of this. I'm just doing it so you can see how it's done. I would have just looked at this and said, okay, I've got this concentration of 4%, and this concentration is 1/100th of that. Okay, so in some way, my answer is going to have to do 1 to 100. Okay, so if this is 100 mLs, then this is probably just going to be 1 mL, and that would have been it. I would have been done. And so this is how you do it with no equation. 0.04 is 1/100th of 4, so I just moved over the decimal 2 places to the left from 4.0. So you see that when I'm kind of saying that, okay, I have 4 here, and I moved it over 2 places to the left, 1, 2, and then I get 0.04. Well, the same thing is true for the volume. You have 100 mLs, and of course you'll have a decimal here. It's not here, but I didn't put one in there, but it's right here after the 0. And it would go 1 to the left, and then that would be 1 ml. So if you're wondering, like, I don't understand, how does that person finish the test so fast? They're not actually going through all those steps. They're just intuiting it because they've done it so many of them before. They're like, oh, it's a solution problem, or a dilution problem, I mean. So how can we make this so this actually sticks in our head? Because I think it's really tough to visualize this if you have some stock solution and you don't actually have a name of anything. And even if you did have the name of a medicine, have you had experience with that medicine to know what it looks like, what color it is, anyway, all that stuff. So what I did was I did this with milk, which is something that everybody probably recognizes. And what I do is I just changed the question from how many mLs of a 2% milk do you need to compound 100 mLs of 1% milk? So it's the same thing. I'm taking a higher percentage to a lower percentage, same number of mLs in distilled water. So our variables are 2%, don't know, 1%, and 100 mLs. Our equation is the same, C1 times V1, C2 times V2. We isolate the variable same way, V1 equals C2 times V2 divided by C1. And now we plug in the numbers, and we see V1 equals 0.01 times 100 mLs divided by 0.02. That's 1 ml divided by 0.02, which is 50 mLs. Now let's look at this one more time and say, oh, well, if I'm going from 2% to 1%, okay, and I'm going to go half, then what I expect is this number will be halved. Okay, so just like we did 1/100th before, we went from 4 to 0.04. We went from 100 to 1. We're going from 2 to 1, and 1 is half of 2, and 50 mLs, our answer is 1/2 of 100. If you want to see some questions like this, I did a book, Memorizing Pharmacy Technician Mnemonics. Again, I know I've talked about it in the last couple episodes. But what I did was, instead of doing the math by the type of math, I did it by body system. So I did a GI problem in the GI section, and a musculoskeletal problem in the musculoskeletal section. But if you've got specific types of problems that are really bugging you, and you're like, okay, well, I want to know how Tony would do this, or then just give me an email or just throw it in the comments on Tony PharmD on YouTube, and just let me know. But again, this kind of math is really all about, and we'll go to kind of the first page here. It's all about this process of, I'm going to take another, let's go to soccer, because in soccer there's an expression that you want to get there fast and arrive slow. Okay, so when I say get there fast, what I mean is the first thing I do is I'm very quick about this. I just, okay, first variable, second variable, third variable, fourth variable. Okay, what's my equation? Okay, let's isolate the variable. Now I go slow because I want to make sure, okay, concentration 2. Let's not accidentally mix up C1 and C2. Okay, I put that one there. V2, 100 mLs. Okay, C1, 4%. Okay, that's going to be there. So when we say, get there fast, arrive slow, we're saying, you can write down the variables very quickly because that's right in front of you. The equation, maybe it takes a minute or two to kind of just like, okay, which one do I need to use? But it's so much easier when you have the C1, V1, C2, V2, like, oh, yeah, I remember this one. I know what I'm doing. And then isolating the variable requires just a little bit of math. And then plugging in the numbers is the easiest part, but the easiest to mess up because, we're a little too fast with it. So again, I want you to succeed in these kinds of problems. So make sure, you take the time to give me a couple problems that you might be struggling with, and I'm happy to solve them for you.